So what I'm going to show you now is a demonstration of some of the new capabilities around the locality sensitive hashing in Stellar. We're also going to show this in the new Profiler UI and give you an idea of, the new Investigator UI, and give you an idea of how an investigator might use that UI to start looking at a problem and then expand back out to investigate that problem in more detail. So here we're going to be working with some data that we got from an academic partner at Carleton University. And what they've done is they've produced these quite interesting devices, which are a canary device. Those run a honeypot service called Cowrie. What that does is essentially sit there, listen for malicious activity, and then report out. So yeah, it's very good for detecting things like botnets, which is what we're going to be looking at here. So if I switch to the Metron Alerts UI, you'll see that I've got this display of a variety of alerts here. And I'm going to pick particularly on this Cowrie one here. In actual fact, I have a saved search for this, and you'll notice that the saved search also updates the columns so that you've got a relevant view for this particular data set. Now, what we've got here is a number of alerts which have a score against them. So these are things that we've caught. So if we just have a look at a few of these, for example, then you'll see down in this threat triage region that these have been caught because they were on a blacklist. So we've added some standard enrichments to be able to find that these have been, or these hosts have been identified as compromised on a threat intelligence source. So that's all very well, and yeah, it's great that we found those, but that's actually pretty straightforward stuff. If we have a look at this one, for example, though, we'll notice that the botnet has tried to be a little bit clever. So the command that's run on this botnet has actually been salted with this randomly generated set of characters to try and avoid things like signature-based protection, because that will change the hash of that command, for example. However, what we've done is produce in the configuration a locality-sensitive hash here. And you'll see that's actually TLSH. That's based on the trend micro locality-sensitive hash, which was originally developed to work with malware detection. So it's for dealing with problems where, say, some script kiddie has changed 1 or 2 bits of a standard piece of malware, which completely changes the hash, and so evades signature detection. The locality-sensitive hash gives you essentially a kind of dynamic cluster out of that. What we've then done is to hash those into bins here using the similarity bin field, which allows us to essentially find things which are kind of similar enough to this input or to the input strings that we've used. So let's again look at this, and let's have a look at from this alert that we actually found from the blacklist. Let's just pivot around that similarity bin. And you'll see that here, yeah, we found this one from this host, which has this particular salt in the command, but we've also found some which we haven't previously detected, which are part of the same attack. So we'll see here where, this is not marked as an alert, it doesn't have a triage statement on, but it does look a lot like it's part of the same attack. So what we're going to do there is to take these and turn these into a meta alert, because they are actually all part of the same thing, and we want to label them as such. So just going to group these together. We'll group them by source type in this instance. And now we've got this set of all of those alerts, which we saw there. I can merge those alerts together into a meta alert. So if I just go ahead and do that, then what we've got now in this search is we've got that single meta alert. Oh, we've got more of them coming through now as well. So we've now got this single meta alert, which includes all of the sub alerts that we've grouped together to be a single unit. So we can say here we have Cowrie busy box attack. So we can give that a name to make it a little bit more intuitive for the end users. We can also add comments against this. So this is from blacklist and similar attacks. So I can add a comment on that to tell other users what I'm up to on this. When I'm pretty sure that I've collected all of these together, and as we've got a couple more which have come in, let me just demonstrate this. I can also add new evidence to that alert, and you'll see that I've got all my existing open new meta alerts up there. I can just add those into that alert as well. So I can keep building up that set of evidence or those set of related pieces into this single unit. I can expand that out to view the details of it, but more importantly, I can now treat these multiple alerts as just a single incident that I'm investigating. If I want to then integrate that out to an external ticketing system, for example, I can also then escalate that alert, which will export it to a Kafka queue so that I can integrate that with my ticketing system, for example. I can also open that to mark the status of the alert so that other investigators can see that I'm working on that, or dismiss or resolve it to mark it as either, in the case of dismiss, a false positive, which we can then use to train machine learning algorithms to provide better scoring of alerts in future, or mark that as resolved because I'm done with it. But it's still useful for historical purposes. So with that, we've seen you have a way that we can find simple alerts from things like blacklists, and then add in the additional alerts that we found from pivoting around this similarity bin, so that we can expand out our search scope through the simple search interface. And of course, now that's just down to a single alert, which is much easier to manage than the huge set that we had previously.